Solve each of the following inequalities for x, where x is an integer. So these are all inequalities. If there were equal signs, it would be a little bit easier to work with, but the inequality is pretty straightforward also. So take the first one. Solve for x, where 3 to the x is less than or equal to 9. First step is to change these bottom numbers. Here's the base level, here's the power level. So these bottom numbers, the base level, you want them to be the same. So what's another way of writing 9? You could say 3 to the second. And then that makes these the same. So it's convenient to write 9 as 3 to the second. Now that you have the base level equal each other, you could say x is less than or equal to 2. So the solution would be x is less than or equal to 2. And notice if you check, and what are you going to check? You're going to check x equal to 2, x less than 2. So x equal to 2 makes 3 to the 2 here. So it makes this part 3 to the second. Here's the 9. And notice it checks out. 9, if you simplify 3 to the second is 9. 9 is less than or equal to 9. So that checks out. The equal sign checked out. Now the inequality. If x is less than 2, well, what's less than 2? An integer less than 2, the first one that you come across is 1. So 3 to the first is less than or equal to 9. And that's true. 3 is less than or equal to 9. So yes, this is a solution. In B, we start off the same way. So you change these two numbers so they could look the same. So rewrite them. You could rewrite 25 as 5 to the second and rewrite 125 as 5 to the third. Simplify. 5 to the 2x is less than 5 to the 3. So now that you have the same base number, now you could work with the power. So now we could say 2x is less than 3. Solve for the x by dividing by 2. And you get 3 halves, which is 1.5. But x cannot be anything but an integer. So the x is not being an integer. So what integer are you going to pick? Are you going to pick x less than 1 or x less than 2? Well, if you check the integers that are less than 1, that would be a 0. And if you put the 0 here, anything to the 0 is 1. So 25 to the 0 is 1, and 1 is less than 125. So x less than 1 works. But if you choose x less than 2, what's the first integer before 2 to the left of 2? 1. If you put a 1 here, 25 to the first is also less than 125. So if you choose x less than 2, that would be more inclusive because it takes care of all the integers before 2, the one that we mentioned and the 0 and all the ones that come before. So the solution is x is less than 2. For this one, we start off the same way. Let's change the 27 and rewrite it so it could have a base of 3. So 27 is 3 to the third. And now that you have the bases being the same, now you work with the power. So 2x is greater than 3, divide by 2. That gives us 1.5. But this is not an integer. Now we're going to have to think about what the x's can be. It can't be a 1.5. Well, we want all those integers greater than 1.5. And which are the integers greater than 1.5? Well, 2 and all the ones that come after 2. So x greater than or equal to 2 would be the solution. For this one, how do you change a 1 to a 4? Well, you can let it be 4 to the 0. Since we know that 4 to the 0, anything to the 0 is 1. So we could sneak this 4 into this position by saying 4 to the 0 is 1. So we could rewrite the 1 as 4 to the 0. Now that we have the two bases the same, we work with the powers. So we're saying here that x is greater than 0. So What is the first integer greater than 0? 1. So all those x's greater than or equal to 1 are solutions. Now, note you might say, well, why didn't you choose x greater than 0 to be the solution? Well, let's see, greater than 0, that would be the 1, and anything above it. So that's the 1, and anything above it. So you notice x greater than 0 is the 1, and anything above it, x greater than or equal to 1. That's the solution.